Uman Rahim here, brothers and sisters. Blessing the covenant and break our seven seals. Brothers and sisters, I'm going to talk a little science today. I'm going to go through it fairly rapidly, because I've talked about this before, and you can review this anytime. The things I'm going to say here, brothers and sisters, are absolutely right and correct, 100%. Talked about this before. I've even written books about it. Devils cannot acknowledge this. They can't refute it. They can't acknowledge it, because to acknowledge this would be to acknowledge me. To acknowledge me is worse than the fall of false Israel. But they respect me. I mean, they respect the knowledge. They respect me. And they respect the knowledge. They want the knowledge, but they don't want me. But they can't get knowledge without me. So they have a dilemma. Because this knowledge is superior to what they have. They know it. They can't acknowledge it. Because to acknowledge me would be fatal. So let's go through it, brothers and sisters. If you want to be a God, you have to understand your creation. Well, your universe. I know I say creation because we didn't create. Okay, I'm going to talk through some of these things, brothers and sisters. Now, the universe is energy, period. It's energy, period. Energy is just mathematics, period. It's mathematics, not a material. It's just mathematics. I'm not going to try to explain it. Right? Let me hold on here, brothers and sisters. Back up. Okay. Again. I've got ahead of myself here. Just energy. Energy cannot be destroyed or created. That means you cannot expand energy because that would be to create it. You can't expand it. You'd be creating energy. You can't contract it because you'd be destroying energy. So you can't do either one of energy. So you can't do either one of those things. So then what happens? Okay? Energy takes, it's like water can turn to ice turn to water turns into something else, transition to something else. Right? Another form of energy. They can't stay in the original form and expand into as the original form because that means you'll be creating more energy. Hope I didn't lose you there, brothers and sisters. So this is going. Okay, let me change something here real quick. Right. That's what I did, and again. I'm going to go through this fairly quickly if I can. Act together here. We'll do it a different way, but you don't mind. We'll do it that way, but well, no, I can't do that. Well, how am I going to do this? Like that. Work. I think that'll work, bro. Yeah. on my spelling system. Yeah. Uh, okay. So we're going to start off like this. In order for the universe to expand, right, it has, what happens is, it's like you put in, like say universe is made of trees of points, just points. You can't see points, there's points. Okay? And that's it. And so you put it, then one of those points turn into a sphere. And so and that's called a neutron. Okay? So it proves that point is, that's how the universe expands by converting points into spheres. Okay? So say that's a neutron there. Okay, which we'll go more in a minute. And then if it keeps pulling it, but it does it in particular, that's where it comes this quantum theory thing, right? It comes in particular units. There's equal units. I can't explain, I'm not going to go into all the math here, bounces, because I'm just going to go very quickly. So in other words, if it expands at force of 1, and it brings a neutron. It takes another force of 2 to turn into a proton. The proton spins. It converts that neutron into a proton, which means it causes a spin. You understand? So that's, if at force of 1, you bring a neutron. At force of 2, you cause a neutron to spin, which is a proton. Right? And that proton spin generates torque. Anything spin generates torque. And that's called electron. The electron is the torque of a proton. Okay? Because proton is a spinning neutron. And there you go right there. So that's the atom. Here's your proton, here's your spinning neutron. And the neutron is plain. I mean, it has no volume to it. Well, excuse me. It has area. It has no volume. Volume is three-dimensional, right? So it's just, right? Okay, just give me pictures here, brothers and sisters. You see here, universe is totally dark. Right? It's spinning very fast, but it's spinning very fast, but hasn't created any neutrons. It's not expanding. Right? Spinning very fast and it's totally dark. Okay? And then, right, it spins so fast that centrifugal force points to turn into spheres. That means that's how it spins, because that point was a little small thing, that's big thing. So that's how the universe expands, by converting points into spheres. So I'm just showing two here, 2 neutrons. Right? And it keeps on doing this. More and more neutrons that expand and create more and more neutrons. Trillions and trillions of neutrons, right? After convert everything to neutrons, then it keeps expanding, right? And they go from force of 1 now to force of 2. And force of 1 creates neutrons. Force of 2 creates protons. Because neutrons are spin. And they spin, neutrons were together. As protons spin, they create a force to keep separate them. So now they separate each other, right? Because the force is pulling them. Not only make them spin, but it's pulling them apart. Okay? And each one has an electron, because the spinning torque creates electron. So now you got 2 protons. We had 2 neutrons before. They got converted into protons. And protons have spin, so they have electrons. Remember, these were neutrons, but it's because the universe more force, spin more force. So I could convert everything to neutrons. Now it's converting the neutrons into protons because it's causing spin. And they go apart like that, right? So now, this is If you take and put those two protons, push it back together, remember there's the force that's pulling them apart. But the force that's pulling them apart is equal to the force, right? The neutron. Force of one. Because you got two there, you got a force of, right? Force of one plus force of one. So you got a force that's pulling back apart. Because if you force them together, you have to hold them in that because it's force that's pulling back apart. But you got some force, and this happens in stars. You got a gravitational force so strong that it's pushing together, right? But you have to hold them together. They won't stay together because there's a force that's pushing apart. If that force that's pushing apart goes away, then they'll push away from each other. But the force that's pulling them is equal to the force of a neutron. So what happens is, if it happens quick enough, instead of that force pulling away, it creates two new neutrons. Oh, here we go. Previous. It creates two new neutrons. And those neutrons, for all practical purposes, absorbs that force that's pulling apart. So now there's no force pulling apart anymore. There's no force pulling apart. No force pulling apart anymore. All right, so let me back up. I go back, I had to correct all this. And this. Okay, see here? So, if you pull, so they're going to try to pull back apart. But if that force creates neutrons instead, now they're stable. Here's the neutrons, compared to the protons. You might force them together, right? And force them together, that force goes away, the star explodes. They can't stay together, but they're close enough together, neutron, and so they're stable now. That's why you need neutron. There's no such thing as a strong force. Strong force is the neutrons is created, right? That's keeping them from coming apart. And if those neutrons are taken away, they fly apart. Just like you did right now, they fly apart. Sure, you see that, bro? And neutrons are created because they're there. They want to fall apart. Then the star explodes. The neutron. Oh, right here. Did this, but I didn't know. It is. Falling apart, right? And what happens is now they're stable because it creates a neutron. So that's what that absorbs the force that was pulling apart. If you move those neutrons away, they're going to come apart. Bam. Explode. That's how you make nuclear bombs and stuff. Okay, let's move on, bro. And if it has electrons, remember each proton has electron. So when it's stable like that, you have two electrons, but electrons, right, based on the I or 1 over R squared rule, right, they're planes. Therefore, you put two of them together and you got a full sphere. Right? So that outside there, that's the electron that's surrounding. That's what actually looks not like a planet going around the moon and all that stuff. She looks. So you got the electron, right? You got two electrons there. They're together. And they surround there because you got two protons in there. And if you got more protons, you have another electron field. But I'm just giving you basics here, brothers and sisters. Give you the basics. So you got two, because you got more protons in there. So you got two levels. This level, you can put up to 8 protons, 8 electrons. That's based on the 1 over R squared rule. I'm not going to go over it. Now, gravity. Now, Einstein had all wrong. All wrong. And quantum mechanics, backwards. Now, what happens is, you see it, that's a proton in the middle. Now, because where you create a proton, the space around is curved. Because they're curved, the space around is curved also. Based on R, 1 over R squared rule again. 1 over R squared rule. right? So it's curved. So it's curved, but the only thing that displaces that space is protons and neutrons, because they're the ones created in the space. Only ones can, right, are sensitive to that curve. So what happens is that right there you see, there you got, in the middle, in the center here, you got a proton, but say it's a whole bunch of protons, neutrons, atoms. I'm just showing one there. So they got whole space around is curved. Because each one is curved, but you add them together. Curves get good, like Earth. Curves it gets more and more because you got each one of them, each atom has curve, it's curved. You put them together, curves gets bigger and bigger and bigger, and spreads out more and more, right? And so, and it spreads out like this. The curvature is greater at near the center. It gets weaker and weaker as it goes further apart. But what's sensitive to the curve, what's sensitive to the current space, is only protons and neutrons. Because they was one created in the space. They're in the space. Because everything is made of protons and neutrons. You understand? So therefore, if it's right there, it's sensitive to the curvature because it says, okay, the curvature near the center is greater than the curvature outside. That means the tension towards the center is greater than the tension on the outside because tension is what's pulling it. That's called the curvature. The universe has that brought into existence by pulling it, tension. So the tension towards the center is greater than tension on the outside. So that means the tension is force. Tension is force, right? So what happens is that the force towards the center is going to be greater than the force on the outside. So the thing gravity is a force differential, not a force, but a force differential, because this thing is experiencing force towards the center more than greater than the force towards the side. So that pulls it towards the center. That's what gravity is. It's a very weak force because the electrons and protons are so small. But protons and neutrons are so small. But electrons are not affected by gravity because they don't have volume. They just, I said they don't have any width. Well, I'm put it that way. They're like a circle. They don't have any volume. Right? So therefore, the gravity, they don't displace space. You understand? They don't displace it in a voluminous way. They don't displace space, so therefore they're not affected by gravity because this doesn't happen to them like this. These affect them because they're voluminous. It doesn't affect electrons. You understand? So what happens is that's why everything falls at the same rate because gravity is only looking at the protons and neutrons. It's not looking at how many of it is. It's looking at protons, neutrons. That's all it does. So an elephant will fall at the same rate as a little kitten. Say, well, that's heavier. Yeah, it may be heavier on the weight machine. But the point is, the gravity sees all it sees is the electrons. All it sees is the protons and neutrons. All it sees. How many of them is electrons, protons, neutrons, and protons? All it sees. Therefore, they fall at the same rate. It works that way. Not like Newton he lied something about the curvature of space, but he had it all wrong. You know. This is actually where it works. It's space displacement. And only protons and neutrons can do that. Okay? When you have curvature of space, that means space on one side is going to be stronger. The tension on one side, because it's tension on one side and greater than the other, that means it's going to move towards where the greatest tension is. It moves towards closer. Okay, here's gravity again now. You got, see, I said it's got a lot there. They move towards where gravity works. Actually works. They know it's actually right. You got a molecule. And the molecule, this fool was talking to Daniel last to kind of tell him, I honestly don't know what the hell he's talking about. So basically, you got an atom here. Remember, if it's got two protons, it has two electrons because it's got two protons here and two neutrons. Neutron has to be there. There's no such thing as a strong force. That's why you have neutrons in there. The neutrons absorbs the force that will actually pull them apart. Because neutrons that force that was pulled apart is the force that created a neutron. So that force created neutrons, so therefore the force doesn't exist because the neutron is the force that would be pulling apart. That force pulled apart produced a neutron instead. So therefore it's stable. Okay. But if you take a neutron away, so on the left side, you got like a helium atom. Because a helium atom has 2 protons. So it has 2 electrons in this shell. The second one has 10, I think 10. So therefore it has 2 in the first shell, because you only can have 2 in the first shell. If you do the 1 over r squared rule, right, then you can have 8 on the second shell. So what happens is that if this comes along, it only has 1 electron, only has 1, right? It needs 1. So what happens is it'll cling on to one of these. See what happened right here? Because what happened is you got 8 here. You should have 10 altogether, but you only got 9 because you got 8 here, 1 here, but this one shares this one. So now he's happy and this is happy. But they combine now because this one needs this electron to be stable and this one needs this same electron to be stable. They share, so now this one has, for instance, this has 2, this has 8. They share in that one. That's what ions are all about and everything. So I'm not, that boy, ooh, folks over there, man. Well, I'm going to very rapidly, brothers. Now, consciousness. And see, it says, make on the queen of planet Earth, God, and universe. Now, I'm happy to say the black spirit, it says the universe. Expands and contracts, right? And it says expand by contradiction, expands by converting energy into neutrons, and from that into protons. Okay. So, and it spins, but as it spins on a triple force, that force is absorbed by the neutrons, electrons. Eventually, the spinning force is gone because all that spinning force was converted into neutrons and protons and so forth, right? So then now it starts spinning, and now neutrons and protons are starting to pull the universe back together. Because remember, they're based on tension. So you, like a rubber band, you pull the rubber band, right? But when you get weak and you can't pull it anymore, they stop pulling, come back together again. Because you don't have enough force to hold it out there, so now the rubber band come back together. So the universe starts coming back together because it doesn't have a force, the strict force that was expanded is exhausted because used that force was converted into the protons, neutrons. So now the neutrons and protons are pulling the universe back together, right? So the thing is, at the center, you have a center, and outside. Because if you didn't have a center, the universe just collapses into nothing. So you got the 2. So what happens here is, as contracting, see, it's hotter and hotter in the center. As you put more pressure on the atoms, and they move faster and faster and faster and faster and faster. Because under more pressure, the greater temperature, the atoms are moving so fast, they're moving up to 24 billion miles per second. That's the speed of thought. That means the atoms in the center achieve thought. The atoms on the side, they move real fast too, but not fast in the center. It's not high as in the center. So it doesn't achieve thought because it'd be 24 billion miles per second to achieve thought, but the ones on the outside, they're not moving that fast because they much greater space. So you got the same amount of space inside as you got on the outside. But the point is you got same amount of atoms on the outside as you have the inside. Right? But the one inside is moving much faster because they're in a small space. The ones outside, they're not moving as fast, but they're hot. They're pretty hot. That's a star on the outside. It's hot. But it's not hot. But it's not. The temperature is not up to 24 billion miles per second. But in the center, it is. I have to get my time around this, but just bear with me. So at the point when the pressure is equal, it keeps going until the pressure on the outside is equal to the pressure on the inside. That's why we're under a whole lot of pressure. That's how a plane that's weighing 1 million pounds can fly in the sky because that pressure is heavy. That shows you right there. How is this air that you can't see can hold a plane that's weighing 1 billion pounds? Maybe 100, maybe 1 billion tons, whoever. How can do that? Because the air pressure is great, but the air pressure inside of us is great as the pressure outside, so it don't crush us because we got a counter pressure inside. So the thing is that becomes equal. But for equal. But inside, that's consciousness. And that inside, the pressure inside is equal to the pressure outside. But the pressure inside is consciousness because That means it's conscious of everything on the outside. It's conscious of everything on the outside. Because both pressures are equal at that point, because that's why it stopped. Both pressures are equal. That's why it stopped. You understand? Stop contracting. Both equal. But the one inside is conscious. That means God of the universe. You mean you're conscious of everything on the outside. You're conscious of the universe. Hope we got that, brothers and sisters. I'm going through quickly. I might take another time later on today or maybe tomorrow with a little more detail, but right. But this is the definition of dimensions here. X to the third is a cube, x squared is a square, x to the first is a line, x to the zero is a point. Derivative. The derivative is, when you do calculus, derivative is that, you see, you take x, or whatever it is, and you make a derivative, and you use this form. You take an n, you put over here, and you take this minus, and that's the derivative. So this would be this. So it was x squared, right? The derivative of a square would be two lines. Because you're going to have one dimension. That's what that means. I'm not good. Acceleration. See? Acceleration means you're taking a line to a point. It means it stops. Changes speed. So before it can go from one speed to another, see, it has to change. It has to stop going at 50 miles an hour to go to 60, or have to go to stop at 50 to go to 40. But that means it has to come to a point stop. That's acceleration. Force, pressure, here's force. But when it spreads out like that, you call it pressure. Understand? Here, acceleration is moving. Before it can change direction or change the speed, it has to stop at the speed it's going. So you call that a point. That's why acceleration is this formula. Move on, brothers and sisters. Sounds going too quickly. It has to come to a point before it can change direction or change. Well, the speed has to stop going. The speed is going to go to another speed. Force, pressure, with this force, the pressure. This pressure is, that's what pressure is. Pressure is force spread out. Okay? Difference. Okay, I'm not going to these theorems here, bro. Since the AB plus, that's what we're talking about right here. This plus this would equal this. No, well, that's a fact, but vectors is just another mathematical way of doing this. This vector plus this vector equal this vector. So I'm not going to all this. Just give you some basics. So again, that's another way of looking at vectors. The vector equation, another way of looking at vectors. Vector components. Okay, this one I'll talk about this for a second. The thing is that vectors work. So here it is. You're going this direction. They're trying to get you going this direction towards the American dream. Right? And here Suleiman's come along and he's putting these vectors, hitting you with these vectors. You're going to change your path to promised land. They need a force to do that. The force is the angel. Keep hitting you with the angel and change your direction. But right now they got you going towards the American dream. No. It's failure. Okay, the circle. Circle 360 degrees. Cut in half, that's 180 degrees. That's how it works. Trigonometric angles. See? So, I'm not going to go into trigonometry right now. You know, just want to give you a brief. It's something you can look at on your own, brother, sister, and look at this. Because if you're going to talk this stuff, you better know what you're talking about. Temperature. Temperature means how fast it's moving. Something moving. Volume is how much there is. So if you got a pot of water, that's the volume. But if you got heat under it, you're going to cause it to start boiling. That's temperature. Temperature is how fast the atoms are moving. Volume is how many atoms there are. Right? Pressures is they're colliding. How much collision there are. Right? How much pressure. I would have a pressure cooker. So, and I'm not going to get into sine, cosine, tangent. That's the trigonometric concepts. Is there any trig? Oh, well, I'm not going to that. Okay. Algebraic equations. I'm not going to get into that, brothers and sisters. Maybe I'll do it all the time. Integral, that's opposite of derivative, and that's the formula for integral, how you convert it. What to use it for? I'll talk about it some other time. I was derivative. I talked about derivative before, so that's the opposite of integral. And it's trigonometric identities. Sine squared plus cosine squared equals 1. Here's the trigonometry. Logarithms, very powerful. Let's deal with exponents. Electron shells. First shell is 2, next shell is 8, next shell 18, according to this law right here. Because you only can put 2 electrons in the first shell. You can only put 8 in the next shell. You up to 8 maximum. Put on up to 18 in the next one. Now here, right here, this is electron. This electron here. There's a proton. Remember, every proton has an electron. Unless it's ion. That means it's missing one. It's attracted. That's how electricity works, by taking electrons away, so the proton will steal electron from one next to it. What happens is, if you take electron, remember that it's at the first shell, right? Or is it the second shell? So move it down to the first shell. Boom, move it. But to move it takes energy. So that's what a photon is. Photon looks just like electron, only it's not an electron, right? It's a wave. So if you shift that down, that's it. On that level, it releases energy, because now it was take energy to hold it up here. But it lose down, that energy goes away. So boom, that's a photon. And that photon comes back and hit it. But sunlight can change something, because sunlight hit it, then you could make that electron, an energized electron. That's the complicated story. I'm not against it. So I said, let's go through it quickly. There you can look at it, and if you can show me anything wrong, I get $5,000. Everything is actually right. But devils can't acknowledge this. But that means they would have to acknowledge me. They can't do that. That's too dangerous. Photon waves. Talk about photons here. Yes. That's what a photon is. Looks like an electron, but it's not an electron. It's a wave. Boom. Move it down. Photon hits it. Well, previous. If photon hit it, it moves it back up. Because it has to be energized. At that level, everything's very what I want to use, everything is discrete at that level. I think I can use that word. Sound waves, magnetic waves, electrical waves, nuclear shock waves, the bomb, fission, fusion. I talked about that before. Fission and fusion. Fission is when you take the electron, knock neutrons out, protons fall apart. Fusion is when you push them together and you create neutrons to keep it stable. If you don't, it come back apart again. That's how they use that knowledge to make atomic bombs. Here's a dragon. Jinn. Iblis. I ain't gonna submit to Adam. Golden calf. Sunnism, that's golden calf. Here's the devil, here's a demon. See, you are the seed of your father. It says father's the devil. So how can he be other than the devil? Demon is a black-faced devil. See, you are from your seed, right? You are from this sperm. Sperm goes to the egg. You were a sperm. That's how you start out. As an egg, you went into the egg and develop yourself. Use that material to develop yourself. But you start as a sperm. So if you came from your father, it means you are your father. Farrakhan, mind, thought. Talk about that a little earlier. Thought waves. Put them out there. They're their thought waves against angel thought waves. I was more powerful. Our frequency, our amplitude, DNA, all biological things, DNA, some subset of it. I spoke that in the past, right? We have the whole combination. All the life forms have some aspect of it, right? We had the whole thing, chromosomes, molecules. Talking about molecules earlier, and a symbiotic relationship. A symbiotic relationship means, you have symbiotic relationships in nature, where like we have a symbiotic relationship between trees and things, right? Oh boy, here we go, this camera stuff. We have a symbiotic relationship. Let me see. We have a symbiotic relationship between trees because we breathe in oxygen and breathe out carbon dioxide. The trees take in carbon dioxide, breathe in it, and breathe out oxygen. You understand? Okay, go again. I didn't get that straight, boss. That's a symbiotic relationship. They depend upon each other. If you get rid of all trees, we die. If we get rid of all us, the trees die. It's a symbiotic relationship. So there's a symbiotic relationship, us and the devils, they created. Because we eat their shit, we produce gold for them. That's what it was back in the fields. It was feeding us chitlins and everything else. It was producing gold and coffee and cotton and everything for them. But they was giving us shit in return. That's what's still right now. And with Farrakhan, you have the same thing. Eating Farrakhan shit, that's what they're giving you, and he's getting rich in return because he's not giving anything but shit. He's not representing Elijah Muhammad, and then not with any shape, form, or fashion. And that works for the devils too. Do the same thing for the devil. We're still doing that for them. We're doing Farrakhan and the devils. They got the devils there. Eating shit, man. We're paying them for it. They're doing the same thing for the devils. This is a periodic table that tells you how atoms, because there's a pattern to it. I'm not going to, here it is. We're doing the same thing for the devils. We do shit and we produce in gold form. We're going to Popeyes and McDonald's, that kind of stuff, using gold form and eating their shit. We're still slaves. You know, that's what slaves look like in the industrial age. Oil comes from topsoil. When stuff dies, it converts into oil. After a long time, it converts into oil. So if you go look at Arabia, for instance, right? You got so much oil there because it used to be a paradise. A lot of life had to be there. And it decayed over millions and millions of years. Now you got so much oil there. Well, it's about to contaminate our underground rivers where we get our fresh drinking water from. So doing energy deprivation, we figured so their technology based on oil said get up out of the ground. Let's all stay all together, brothers. Here's 5 pillars. I talked about this. That's what you need. That's how that's your way you made up, brothers and sisters. That's your nature there. You don't know that. Woman is tied to the moon. That means that when the moon was created, brought into existence, that was a separation between the gender. That's the proof right there between the male and female. Before that, you were genderless, and that's when the male and female was separated at that point. Because the sign is the woman's reproductive cycle was tied to the moon. But before that, what was tied to it? She was just before that. Star. Okay, I'm going to talk just a little bit about this. I'm going to go. This is right here. I hope I didn't. So what this means is that the Earth goes around the sun in an ellipse, but it sweeps out the same amount of air, the same amount of time. So when it's closer, that means it's going to move faster. You get this much area. This area is equal to this area. This is equal to this area. Previous. This area, this amount, if you allocate Calix area, all of them equal the same amount. Okay? But therefore, to go fast enough to create this much area, right? It has to move slower, but he has to move faster. In order that much area, okay, same thing. So that much area to be wiped out, to be created. That's why the Earth moves faster at some points and slower at other points. When it's close to the sun, right, it moves faster. When it's close to the sun, that's in the wintertime. It's actually close to the sun in the wintertime. It moves faster. When it's further away from the sun, it moves slower. Up here. Well, it's like here. It moves faster here, slower, and really slower here. Because it's farther away. So it's closer to the sun, it moves faster. It's slower, further in the summer, it's right. When it's closer, actually, that's when it's winter. Closer. Because of the ellipse. Well, I'm leaving it there, brothers and sisters. I was going to go through this quickly. So if you're interested, you can follow it up. I'm leaving it there, brothers. Assalamu alaikum.